Okay, so in the bonus on the practice worksheet, x cubed plus 3x squared plus 3x plus 1, that's a cubic 4-term polynomial, so I'm going to use my graphing calculator to help me factor it. So I put that in my y equals, I do zoom 6 to look at the graph, and there I can see it's wiggling through, it looks like -1. So let's do trace, put in -1, and sure enough, there's a 0. And that has multiplicity of 3 since it's a wiggle at that 0. So I'm going to go to my numerator, and that's going to factor as x plus 1 with multiplicity of 3. Then the denominator is a difference of squares, so that factors as x plus 1, x minus 1. And I have a common factor of x plus 1 in the numerator and the denominator. I can cancel. That's going to change my exponent from a 3 to a 2. And x plus 1 quantity squared over x minus 1 is going to be my simplified form. So to find the coordinate of the whole, I set that canceled factor of x plus 1 equal to 0, subtract 1 from both sides, and x equals -1 is the x coordinate of my whole. Then I'm going to take that x equals -1 and substitute it back into my simplified form. So I have a -1 plus 1 quantity squared divided by -1 minus 1, and that's 0 squared divided by -2. 0 divided by anything is 0. So -1 comma 0 is going to be a whole in the graph. Okay, then my vertical asymptote comes from setting the denominator equal to 0. So x minus 1 equals 0. X equals 1 is going to be the vertical asymptote. So we'll go ahead and sketch that on the graph. And it looks like my hole is not very empty in the middle, so I'm going to clean that up a little bit. There we go. Okay, then to find coordinates of zeros, I set non-canceled factors from the numerator equal to 0, but I can see that that's going to produce the same ordered pair as my whole, and a whole cannot be as well a real 0, so there would be none for my x-intercepts. Then to find the y-intercept, we put 0 in for x in the simplified form. And so we have 1 over -1 is -1. So 0, -1 is going to be the coordinate of the y-intercept. Okay, then we've got equation of horizontal or oblique asymptote. For Bobo Botan eats DC, this is quadratic on top and linear on the bottom, so it's bigger on top. So that's the Botan, B-O-T-N, bigger on top, none for horizontal, which means we have to have an oblique asymptote. So we're going to do the division here in order to find that oblique asymptote, which means I need to expand my numerator back into standard form. So x plus 1 quantity squared, that's a perfect square trinomial, which is x squared plus 2x plus 1. So I use a 1 out front for my divisor of x minus 1, and then the coefficients are 1x squared, 2x, and the constant is 1. And I bring down the first value. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 1 plus 3 is 4. The 4 is the remainder, preceded by the constant, preceded by the x. We discard the remainder, and then y equals x plus 3 is going to be the oblique asymptote. So we come over here to a y-intercept of 3, and the slope is 1. And so this would be my dashed line for the oblique asymptote. And then it says that 3 comma blank is a relative minimum. So I'm going to put 3 in here for my x value. So I've got a 3 plus 1 quantity squared divided by 3 minus 1. So 3 plus 1 is 4, squared is 16, divided by 2 is 8. So the point 3 comma 8 is a relative minimum, which tells me that this hyperbola is shaped by that vertical and oblique asymptote with a turning point here at 3 comma 8. Then I can do the same thing down here, and there would be my graph of the f of x. Okay, the domain is being impacted by this hole here at -1, and also by this vertical asymptote at +1. So the domain is going from -infinity to -1 for the hole, union -1, and then scooting over here to that asymptote at 1, union, and then other side of the asymptote 1 to infinity. The range is bottom to top. So we're going from -infinity until this relative maximum at -1 comma 0, but that's a hole. So that 0 is non-inclusive. Then we have a big gap until we reach 8. That 8 is a relative minimum that is inclusive. So we have a bracket on the 8, and then the graph extends up to +infinity.